Artificial Neural Network, or ANN, can be called a simulated neural network, or SNN. This is a picture of human neural cell, and millions of them live inside and works in our brain daily and never stop. And that's what inspires most of computers engineers to make an artificial intelligence applied in the computers. And that's what we call an artificial neural network. First thing first, I want to tell you that human neural cells can be simplified and divided by three parts, such as dendrite, axon, and cell body. Each of them has its own function. For dendrite, it has branched projection of neuron and send impulse to body cells. Axon has a function to send impulse from body cells to another cells in the body. And cell body is the most important thing. The function is factory of the neurons and produce protein or dendrites and axon. Artificial neural network on computer. How is that happen? Let's just re-analogize it. Here we have three kind of square. Each of them represent important things in computer engineering, such as input, process, and output. For example, we want to input 2, and then we process it by multiply with 2, and the output process is 4. And if you're wondering what happened in our brain when we want to shoot this confused guy, first, we see him, and then we process it in our brain by our neural brain cell. And our brain will give the output, which is, in this case, is to shoot a guy. And bang, that guy is killed. And this is how it looks like, our neural brain cells. It's in the random position, jumbled mass, interconnected, and cannot be computed. And it looks a bit like a graph. This is to represent a real neural network on our brain. But how to compute it? To make it simple, scientists usually use this kind of models. It has input layer, hidden layer, and output layer. And this one things is called nodes. It's layer by layer design, it has coloring, simpler, and hidden layer can be more than one layer. But how about those layers? Input layers. A set of input units which take in information about the example to be propagated through the network. By propagation, we mean that the information from the input will be passed through the network and an output produced. Second is the hidden layer. A set of hidden units which is take input from the input layer, the hidden units collectively from a hidden layer. For simplicity, we assume that each unit in the input layer is connected to each unit of the hidden layer. But this isn't necessarily the case. A weighted sum, the output from the input units from the input to every hidden unit. Note that the number of hidden units is usually smaller than the number of input units. The third is the output layer. A set of output units which, in learning tasks, dictate the category assigned to example propagated through the network. The output units from the output layers. Again, for simplicity, we assume that each unit in the hidden layer is connected to each unit in the output layer. A weighted sum of the output from the hidden units form the input to every output unit. And there is also another term. It's called epoch. When we give an information to an input layer and then process it in hidden layer, and then we have an output from the process that it's mean one epoch. Not more epoch we get, more better we get the result. there is also weight. The higher weight of an artificial neuron is, the stronger the input which is multiplied it by it will be. Weight can also be negative, so we can say that the signal is inhibited by the negative weight. Depending on the weight, the computation of the neuron will be different. By adjusting the weight of an artificial neuron, we can obtain the output we want for the specific input. The thing that's also important is each node can only receive 0, 1 input, output, or hidden, not binary, but only with a range of 0 and 1. For example, here we have a node. This output circle contains 0.4 for read information or contains 0.25 for input. And for your information, the amount of hidden layer, whether it's node or layer, is not the same. You can use many nodes as you want, as you need it. This is the last example of simple artificial neural network. Here we have a few nodes of input layers, 3 nodes of hidden layer, and 2 nodes of output layer. Each of them is interconnected by some way, and it is depending on your needs. For example, here we have A and B for input layers. Then on the hidden layer, there is some mathematical process and formula or even function in each node. We can say there is C in the hidden layer, and after computing on the hidden layer, there we have X and Y on the output layer as a result. If the output node contains more than 1 or less than 0, then that layer is called errors and must return the process until it has range between 0 and 1.